Hi, this is Ms. Fazone. This is, objective number 10, not 9. I added a day in. Graphing polynomials that are in factored form. So we've spent the last week kind of working on graphing, and this is kind of, as long as it's in factored form, we're going to get a little more difficult. Okay, so let's look at these basic graphs and what they look like. Right? X squared. X squared is just a basic parabola. Okay. X to the third. Remember, it's like steep parabola here, and then it drops down on this side. X to the fourth, a fourth goes in the same direction. So it's like a very steep parabola, like that. And then an x to the fifth also looks like an x cubed, where it goes up really fast. Should be faster than that. I didn't do a very good job of showing the difference, but it's even steeper than an x cubed. Okay? All right, so now, today we're talking about multiplicity. So what happens when you have a quantity squared? So x minus 2 quantity squared. So what's the vertex of that? Well, it's got a root at 7, right? So 7, there's our root. Okay. And it goes up in both directions. What's the local extrema? Well, that's just the vertex. It's a parabola, 7, 0. Where is the graph increasing and decreasing? Okay, so increasing, decreasing. Remember, we write intervals for this. So increasing, where is it going up? Well, imagine a little man walking. He's going uphill on this side. So 7, and then when does it stop increasing? Never. So it's going to be 7 to infinity. Okay. Decreasing. Now remember, we go left to right. So if you started over here and went down, that's decreasing, but remember, left to right, just like we read. So imagine the man is right here. He's going downhill to 7. So what's the arrow mean, though? It means infinity. It's actually the negative infinity, though. It's not negative here, but eventually, as it goes up, it does go to negative infinity. Okay? So that's the answer. Okay? All right. Next one. Now, we did ones like this, but look how this is different than the last one. This has x minus 3 quantity squared. Okay? So in this, it's going to be a little bit harder. So let's start with the zeros. Where are the zeros? What are the roots? So we switch the sign, -6, and x equals 3. So that starts our graph. So 1, 2, 3. So x equals 3. And 1, 2, 3, 4, 5, 6 is right there. So those are my two roots. Now, what's happening as we go to infinity? Is it going up or down? Well, it's x times x squared. So this is an x cubed problem. This is an x cubed, right? X, and we have x squared. So as x cubed goes to infinity, what's happening? As x goes to infinity, y goes to infinity. A big number to the third is a big number. So this one, it's going to go up like this, right? How about as x goes to negative infinity? Oops. That'd be helpful. As x goes to negative infinity, and remember, what's a negative number to the third? Negative infinity, right? Oops, that's a y. So this one is coming down, right? Now, here's the tricky part. How do we attach these? Think about it. All it is like that, right? This is called a multiplicity. Because x minus 3 is quantity squared, there's actually, imagine, cover this up. There's like a little parabola that touches right at 3. There's a little parabola that touches right at 3. So so 3, it doesn't go through at 3 like all the other graphs did before. It actually touches down like that. So we have a vertex at 3, right? So the local extrema, one of them is 3, 0. Now, what was our rule for finding the other one? Right? So what's this distance? -6 to 3. What is this? That's 9. What's half of 9? 4.5. Okay, so I need to go 4.5 away from these. So it doesn't matter which way you count, but 1, 2, 3, 4.5. So that's this point. So what is this x value? -1.5. So comma, -1.5. And then we plug in to find the other one. So I need to grab my calculator. Okay. And I'm going to plug in parentheses, -1.5 plus 6 times -1.5 plus 3 squared. 10.125. 10.125. So that's this point.